All right, hello everyone. It's time for another Helios Spotlight interview, and this is the second interview we've done with a member from the UX Network team. So today we've got Guillaume, who previously or maybe still with EOS Titan and also the UX team. So Guillaume, thanks for being here.
Thanks, Chris. Thanks for having me.
Maybe just before we get into discussing some of the new announcements and a bit of a walkthrough on stuff coming out on UX, maybe just a quick background about yourself and what got you here.
Yeah, sure. I guess my background is mostly finance. I've been been working in the quantitative finance, algorithmic trading space pretty much my entire life. Back in the days, I guess it was in the quote quote legacy financial system. And back in about 2011, I discovered Bitcoin. So I kind of transitioned my skill set from traditional finance into crypto finance, as I would call it, I guess. Mm-hmm. And never looked back. Always been always been moving forward since then in that direction. So back in 2013, 2012, essentially, I decided that I was going to do crypto exclusively moving forward. So I was no longer going to be working in the equities or Forex or derivative space in traditional markets. I decided I was going to do only crypto. 2013, I co-founded the Montreal Bitcoin Embassy, which was at the time the first physical space dedicated to Bitcoin and cryptocurrencies. We did quite a bit of, public education, regulatory outreach. We were working with a lot of regulators and elected member of parliaments and the Senate to try to educate them on Bitcoin and crypto in general. We had an incubator where we helped out some startups with funding, with mentoring and technical assistance to help launch their products, and a lot of them are actually quite big these days. So that worked out pretty well. And then eventually I decided to get back into active software development around the time where when Ethereum was launched. At that point, I've always been quite fascinated by the concept of smart contracts and what is now known as DeFi. Back then it was we didn't call it that like that, but that's always been something that's been quite interesting to me because of my financial background. And so I got back into software in 2015, but Ethereum was not exactly yet where I thought these platforms needed to be. Mm-hmm. So I kind of just like lurked around, looked at what was going on and everything. And I guess it's really when EOS was announced that I finally said, okay, this is it. This is the platform that is going to allow me to build what I had been envisioning, what I've been thinking about, and decided to launch a block producer team with a few of my friends and colleagues and other people that I've met throughout my crypto journey. So we launched EOS Titan just a few weeks before the launch of EOS Mainnet. We became a standby block producer. Never got elected in the top 21 on EOS Mainnet, okay. But we've been pretty much there since the start. And eventually, I met with Darren that you interviewed a couple of weeks ago. Who was an investment banker, and we had an immediate connection, had very, very similar thoughts and views on the whole market, on the whole landscape. So we decided to partner up, create Origin Ventures, which is the company that launched UX Network and that has launched a number of other things. And we're in the process of launching even more stuff. So that's my background in a nutshell.
Yeah, cool. Well, you caught on early on, and you've got kind of a perfect background to bring it. The idea of mass adoption in crypto, a lot of us sort of recognize it needs to be somewhat familiar to the traditional space. So you having that traditional finance background, you're going to kind of hopefully make that transition for some of these holdouts a little easier to come into the decentralized DeFi space.
Yeah, and I was also very lucky because back in 2013, when we were at the Bitcoin Embassy in Montreal, it was very early on in this whole ecosystem, and we were full time in it. We met with all of the like thought leaders, with all of the smartest people in the space, had a very great opportunity to discuss all these concepts, all these ideas very early on with some of the brightest minds in the space. So I was able to soak in like a lot of knowledge, a lot of insight, and a lot of information at the time. So that's that puts me in I guess like a quite privileged position, I guess, to it's an industry that is whatever like I guess like 11 years old and or 12 years old, and I've been in it for like 10 years out of 12. So it's pretty
Hard to believe. It's time flies, eh?
Yeah.
And it's fine. I got into, a little after you, or quite a bit after, really. End of 2013 is when I heard about it, about Bitcoin. And even though like that moment I heard it mentioned on the radio, I was driving my car and they mentioned the price and it was like 2017 or something. I was like, oh man, we're here, we made it. Bitcoin's finally there. But even now, still today, 2022, there's still so far to go. Like in terms of really bringing in all the,
and in this this macroeconomic context also, it's quite phenomenal. Like these days people are seeing, I was reading an article a few days ago that was saying that there was about like $100 million of donations that were sent to the Ukrainian government in this whole situation over there. So that's quite impressive. Like this is highlighting like in a very like boom in your face, like the utility value of cryptocurrencies. It's quite like, what a time to be alive. Let's put it this way.
Right. All right. Well, okay. In that vein, so UX Network, recent project, right? Lots going on. It's an EOSIO chain, so it's not EOS, but it's obviously using the same underlying protocol. Do you want to kind of speak to sort of your intentions and what are you hoping to achieve with UX?
Yeah. So I guess from our standpoint, I mean, we've always been with Yes Titan quite at the like forefront of what I would describe as resource management on EOS mainnet and on blockchains. Like back in the day, around like in September 2018, we launched the EOS Mechanics initiative with Greymass and EOS, Aloha EOS, which was essentially like meant to help benchmark the performance of block producers. So like try to kind of squeeze as much performance as possible from the network, and that became adopted like by just about everyone in the space. Now every chain is running EOS Mechanics. Like they're always benchmarking their block producers and their full nodes. Block One has also been using EOS Mechanics benchmarks to tweak their own software and work with work with it for the release of EOS VM and other iterations of the virtual machine that the blockchain, that the EOSIO stack uses. So we were very interested by these topics, and quite like the way that Block One released the original EOSIO with the staking model, we thought was very innovative as well, because instead of having to pay transaction fees, you would buy the token if you wanted, stake it, and then obtain some like resources that you could use to perform transactions on the network. And unfortunately, they decided at some point to move away from that model and to go with I guess like the power up model, which we felt was not a very good idea. Like it was kind of going back more towards like what Ethereum was doing, with more like not quite a transaction fee, but not exactly as flexible as the staking model was. And we like one who asked for comments from block producers with regards to power up model, and most block producers were like, oh yeah, this is great, this is fantastic, blah blah blah. But we were like, no, this is not good. This is a bad thing. This is a move backwards. And we suggested a number of improvements or alteration to that model instead, to solve the problems that they were trying to solve. But they ended up doing the power up anyway. So at that point we said like, no, this is not going to work with our vision, with our approach. So that was probably like the main catalyst for the creation of UX Network. So what we did with UX Network, we we implemented a number of different features. Our resource model is one of the key differences. This resource model essentially looks a lot more like the old staking model that was on EOS, except we removed this elastic leeway because back then, like, there was this mechanism when the chain is essentially being used a lot by the users, the quota of resources that you receive from staking essentially like diminishes, and when the chain is not being used, it increases. So it kind of like automatically, if you want, like balances it's a bit like on Ethereum, like the gas fees. Like when people are using the chain a lot, gas price goes up, and when people don't use it, it goes down. But the problem with this is essentially it makes it pretty much impossible for any business to forecast what their costs are going to be. And we were talking about mass adoption earlier. In order for mass adoption to occur, you need to have a predictable way to price these resources to be able to say, okay, like I'm going to have like 1 million users doing 10 transactions per day for the next like whatever 5 years, and I need to be able to know what's that's going to cost me. And I cannot like it's just impossible to like try to forecast like the gas prices and then the token prices, and then like, you know, like someday it costs nothing, the other day it costs like $100 per transaction. That makes no sense. Like nobody's gonna like be able to build anything meaningful on a platform like that. So that was probably, in my opinion, this is the main improvement that we have. We essentially like build that resource model to be extremely precise in this price discovery of what these resources should cost, and have a very transparent way of pricing them, as opposed to just about any other blockchain that is kind of like an algorithm that you can't predict in advance, that just like makes it impossible for a company to deploy. Another special feature that we have is we have a true immutability of smart contracts, which is optional. It's not by default. Like by default, smart contracts are just like on EOS mainnet or on other blockchains. Essentially, like the developer can change the code of the smart contract, and eventually, like block producers can also change the keys or overwrite the current code of a smart contract. So we do have that, but we added also an option for a smart contract owner to make that smart contract immutable. And when I say immutable, it's immutable even for block producers, meaning that if I own an account and a smart contract and I decide to make it immutable, even the block producer's God mode, that infamous God mode that allows them to change the keys or to overwrite the code that exists on a smart contract, that won't work if the user marked their contract as immutable. Wow. And this is one of the main, I think, one of the main big misses from like Block One when they released EOS, because at the end of the day, it's not the block producers or the validators or the miners that should be enforcing the consensus. It should be the full nodes. It should be the users. If you're running version X of the software, you should be like, like this is what you consider the real version of the blockchain. If you are a block producer and you can change the keys to accounts and you can change the code of other smart contracts, even the ones that are not like explicitly assigned to your control, well, you're kind of starting to recreate the old system where there's an all-powerful group of people that can make decisions without anyone else being aware and without obtaining like a broad consensus. And unfortunately, this is kind of like, I think, one of the reasons why EOS has been underperforming. When all of these at the beginning, it was ECAF that was issuing these orders, and block producers were complying, like blocking transactions. Eventually, they started changing the keys. I mean, they did that I think twice, but they changed the keys to accounts and whatnot. And in the EOS ecosystem, people like probably thought it was kind of a good idea. But if you look at what people were saying outside of the ecosystem, they were like, what's the point of a blockchain if it's not immutable, you know?
Yeah.
So on the other end, we also thought it was quite nice from a development perspective to be able to change smart contracts, to upgrade them, to fix bugs and things like that. So we went with that hybrid approach where it's mutable by default, but if you want to have it to make it immutable and like set in stone, you also have that option. So best of both worlds.
That seems so obvious but I mean, not knowing the technical know-how, it's just, is it possible? It sounds like obviously it is. Is that something, can that be toggled later on, or is it upon contract deployment that it has to be set to being immutable or not? Or can you change it?
You can make it immutable at any point after it's been deployed. So like you can deploy it version 1, and then like after a couple months or like years if you want of testing and just like battle hardening the smart contract, you can set it to immutable. But once you set it to immutable, then it's done. You can't go back. Exactly.
Well, that's brilliant. That's bringing in that Bitcoin-esque immutability that we all like. So, you know, getting to Bitcoin as early as you did, that's one of the big drivers, is like, this can't,
of course,
this is unconfiscatable. The governmental authorities can't just edict something to happen on chain, which EOS we've seen can happen. And we are even with the recent controversial block 1 account freeze, or at least freezing of the vesting contract, that everybody agreed with that. And that's sort of, you know, you look to institutional investors who are considering dropping large amounts of capital onto a blockchain. That's a bit of what happens if...
Exactly. That's exactly the reason why, because we like most of our I guess like the management team of UX Network comes from that institutional investment like ecosystem sector, and we speak with people in that space, and for them, like it's a big no-no. Like if you have something that is mutable, where the developers or block producers or miners can rug pull at any point and like they can do what they want, like they're just not interested, you know?
Yeah,
it's just not going to work. It's not going to work for their use case.
And especially when you consider the idea that a lot of these people getting into Bitcoin now, or crypto now, Bitcoin's their first exposure, and they learn of that hardness of Bitcoin. So then they start to look at these smart contract platforms. Yeah, a lot of utility, a lot you can do, but if it doesn't have any of that hardness, it's a turnoff. So Ethereum go to, except it doesn't have the performance that EOSIO has. So this is awesome. I did not realize that this was a feature of your chain, and I've done some research, so I should have known. But so I'm glad this has come out now. We'll definitely spread the word on this, because that's a pretty wicked additional feature that you've got.
I think so too.
Okay, so let's dive into some of your presentation. So I'm going to put your screen up here, and maybe you can kind of just talk us through what we're. So maybe actually before we go here, before I throw people's eyes off, in terms of the rollout, we're going to go over your bridge technology, and that's basically inter-blockchain communication essentially.
Yeah.
And this is strictly between EOSIO right now.
With Ethereum, pretty much being we're putting the final touches to that side of that bridge, and we're going to be doing Binance Smart Chain next.
So those are all okay. Awesome. All right.
Yeah.
All right. And then here, let's share it, and then you can talk us through.
All right. So essentially, like maybe I can talk a little bit about it, like give a little bit of an overview, and we'll do a quick demo, and then we can talk some more about some of the most important concepts, I guess. But so kind of following the same kind of ethos that underpins these decisions, like full immutability or optional complete immutability of smart contracts. When we started looking at IBC, like methods or process or techniques, we realized that most of the existing solutions did not really, respect that ethos. They were typically, what are called like federated oracles or multi-sig oracles, where you have a group of people that say, we're gonna essentially monitor a smart contract on chain A. Something happens there. then we're gonna essentially agree that this event occurred, and then we're gonna create another event on blockchain B, and essentially like this is going to be the IBC model.
Right.
The most common use case when we talk about IBC is probably like the I guess like the wrap token, where you have a token on chain A that you want to move to chain B and make it available on chain B for trading, selling, exchanging, and then have the ability to redeem it, bring it back to chain A at any point. So Alice like sends that token to that smart contract. Like it gets replicated on chain B, sends it to Bob or sells it to Bob. Bob sends it to Charlie, and Charlie decides that he wants to redeem it back on chain A. He can do so and just like get back the original token on chain A and be done with it. So that's the general use case of IBC, but it's not limited only to that. Like technically, any action, any transaction that occurs on a given chain could be proven, could be reported to the other chain, and could have something happen based on that transaction. So in a traditional, I guess, or I say traditional because this is mostly how everyone else has been doing it. In a traditional IBC solution, you have a group of oracles that are going to be observing what's happening on chain A. They're going to report it on chain B, and through a multi-sig, so it's going to be like a 3 out of 5 or a 4 out of 7 signatures required, or whatever number. But obviously, if you do it like this, you introduce additional trust in the whole ecosystem, like in the whole process. Like, who are these signatories, and at what point will they be interested in colluding to like steal everyone's money? Like if you think about it, like the kind of thought experiment that always comes to mind is, imagine you have Bitcoin that is locked in that smart contract. How many Bitcoin does it take for that group of oracles to decide that, hey guys, like we're just gonna take it, rug pull, and disappear, and and just
it becomes this honeypot, right? It's this honey.
Absolutely
creates more hazard. So
exactly, and the thing is, the more like funds are held under the contract, the bigger the reward for like malicious actors. So it's always like a very difficult problem, because it seems it's fine, and until it's not, until like everyone like fuck off with the money, so essentially we decided that was not going to work for us. This was not a valid approach because of that additional trust that was required. You're already more or less trusting the validators of your blockchain, and since you have two blockchains that are connected together, you trust the two validators, the two sets of validators to maintain these two blockchains. So our requirement was that we wanted to have an IBC technology that would not require any additional trust. Like, you take your two sets of validators that you already trust, and you need to be able to perform that transaction without involving anyone else, any third party, any additional service provider or oracle or validator other than the ones that are already there. Now, the other problem that you have also is it has like typically people that went a little like one step beyond that multi-sig oracle. What they ended up doing is they created some sort of cryptography based like implementation of the simple payment verification protocol, which was a protocol described originally by Satoshi in the white paper, the Bitcoin white paper, that essentially allows you to verify transactions occurring on a blockchain with only the block headers. So you don't need a full copy of the blockchain. You only need a copy of the block headers. And then with this, you're able to prove that a specific transaction was included in the chain's history, in the chain's Merkle tree, and essentially like use this as some sort of a mechanism to talk between various blockchains, or a blockchain in the thin client or whatnot. So that's fine. That's a great approach. However, it is extremely clunky from a I guess like a technical perspective, because now you need to copy all of the block headers from chain A to chain B, and vice versa if you want to have bidirectional capacity. And in the case of the EOSIO chains, as you know, like the block time is 0.5 seconds. So that means a constant chatter between the two chains. That was the model that was implemented back in the day by Bus Core. I don't know if you remember in the early days of ES Mainnet, there was a chain called Bus. And they implemented that IBC, which was quite good, but it required, first of all, like constantly to have this sort of relayer system that was relaying the block headers from one chain to the next. And then that relayer had to be like somewhat trusted as well, because like you have to be kind of whitelisted to be a relayer. And it was generating like tons and tons and tons of transactions both ways. So obviously costing a lot of resources, like loading the chains and all of that. So that was also not like good enough for us. We felt like that was kind of wasteful, and also created, like, still maintained that kind of central point of failure. Although that's a lot better than the multi-sig oracle, because now under this approach, that relayer cannot rug pull, cannot leave with everyone's funds and whatnot, but you still have that central point of failure. The relayer could selectively prevent some transactions from going through and things of the sort. So that was not a good solution.
And reliability issues,
reliability issue, and
so much throughput.
And that's exactly what ended up happening with Bus Core. At some point, the guys like the price of the token went down, and at some point the people running the relayers were no longer interested in maintaining this. So the relayer went down, and a bunch of people had tokens stuck on the other chain for months and months and months. So that's kind of proof is in the pudding. In that case, like, this is how these kind of systems will fail. Like if that centralized third party goes down or gets captured by regulators or something like that, it just doesn't work. So for us, that was not an option. We had to like our approach, the requirement had to be that the user doing the transfer like had to be able to do it by himself without relying on any third parties whatsoever, and without any additional software or any complicated setup or something. It has to be something that can run as a simple process, either on a client or on a server, that is essentially like a very quick like a snippet of JavaScript code type of thing, where you can just add it to your to any UI or any server process. You don't need anything special or whatever. So we came up with that solution that essentially allows the user to be the carrier, if you want, of all of the proof elements that are required to demonstrate without a doubt that this action took place on the source blockchain, to prove it on the destination blockchain, and then like the smart contracts on both sides just do what they're supposed to do. So in the case of a wrap token transfer, what you do is, as a user, you log in into like a front end or whatever it is, like any like a wallet based, like Anchor or Scatter based, like a website. You send the transfer to a smart contract, you sign that transaction, then you essentially query the API node for some proof elements, and then you package these proofs, send them to a smart contract on chain B. So you sign another transaction to prove that action on chain B, and done. Like you've got your tokens transferred from chain A to chain B. So if you want, I can maybe give you a small quick demonstration of how that looks like. One of the things I guess like the elements that we're gonna need to improve over time is gonna be the time that it takes, because right now we are essentially following the same consensus model than EOSIO, which requires essentially like a number of block producers to sign a block on top
for finality.
For finality, exactly. So because of that, it takes a few minutes for the whole thing to complete, but it's done in a way that guarantees irreversibility of these transactions. So meaning that if I follow this process right now, I am guaranteed 100% that this transaction will not be reversed, that these tokens will be accounted for on both blockchains, and that essentially there won't be a fork that will invalidate the state of either blockchain at any point. So essentially, we have it set up right now between our EOS testnet as well as our UX testnet. These are private testnet that we maintain. So you begin with simply like connecting, logging in with Anchor, for example, the one that everyone uses, on both blockchains. So when you
and this means you'll have an account, obviously, then on both chains, right?
Yeah.
And they can use separate usernames, separate keys. It doesn't matter. You just log in.
It doesn't matter. Doesn't matter. You can use either account. You can send to your account, obviously, on the other chain, or you can send it to another. Well, actually, no. You have to send it to accounts that you control, because you need to sign the transaction on both sides. You need to send the original transfer on chain A and then the proof on chain B.
Got it.
But so like now I'm gonna just enter, say, whatever 2 EOS that I want to send from EOS to UX. Click transfer. Now it gives you like a confirmation window. Just click confirm. Now you sign that initial transfer. So what's happening here is we're essentially sending tokens to the smart contract on, in this case, the EOS testnet. We're locking these tokens into that bridge, and we're basically now waiting for enough blocks to pass so that we're able to construct a proof of this irreversibility final transaction. The way it works is essentially you have to wait until 2/3 plus 1 of block producers added a block on top of the block that contains the action that you want to prove. Again, as I was saying earlier, typically this is the use case. This is a wrap token that you want to move from chain A to chain B, but it works with everything. Like you could prove like a vote for a block producer. You can prove like a staking or unstaking action. You can prove just about anything that anything really that can happen on an EOSIO blockchain. So that allows you to create really, like, I guess, distributed smart contracts across multiple chains. And it's quite interesting because you can, by doing so, you dramatically extend the flexibility or the capabilities of these chains. Like you can have, for example, like your user account is on EOS mainnet. You could have, for example, staking a token there would give you resources on another blockchain and would allow you to perform, for example, like distributed voting. You vote on chain A, and the the result of that vote is taken into consideration somewhere in the governance of chain B or C, or so it gives you like massive flexibility. So now, as you saw, like the transaction went through. Now I've gathered my proof. This is like the cryptographic proof that I need to sign. I sign it. I basically report it to my destination chain, and it's done. Basically, I have now like 2 EOS that were in my account on chain A that are now locked into the contract, and then 2 like wrapped EOS have been created, have been minted on UX network. So you can see like the transaction logs here, and then basically like you have now this control over that 2 wrapped EOS on UX network. You can do what you want with it, sell it, trade it, exchange it, and at any point, anyone who has these wrapped tokens can do the reverse process, essentially burning these tokens on EOS mainnet on UX network and reporting that action back to EOS mainnet to unlock the real EOS that's held in the smart contract. So this is it might take a bit of time for people to digest the whole thing. It's there's quite a few things going on behind the scenes, but this is the proper way to do this inter-blockchain communication, because as we follow the same consensus rules of the underlying chains, and because we wait for this finality, you are guaranteed to always have a matching state on both sides, and you won't ever run into the kind of issues that have been plaguing these other chains with like these other bridges that eventually fail, or people get rug the Oracle's rug pull or things like that. This is 100% consistent with the consensus mechanisms of both chains, and it is something you can like build on with confidence. Like this is not going to break. I mean, hopefully, like our implementation has no bug and everything. Like we're gonna want to have I guess like a few more pair of eyes on the code, but we will open source it in due time and invite the top EOSIO people to take a look and provide their thoughts and probably have a bug bounty or something like that to try to break that thing. But the design is sound. Like the approach is very sound.
So I guess, so lots of questions I have now about this. So when the EOS is being sent from my account and I'm going to receive it on my UX account, where does it go on the EOS network? What is there a pool that's still aggregating all these tokens into one
Exactly. So we have there's a few moving parts. We have essentially on the source chain, you have what we call the wrap lock contract. So wrap lock contract essentially is the contract that holds the native asset, the EOS in this case, that holds it there. And essentially when you lock your EOS in that wrap lock contract, it generates an inline action that is now relayed to the other chain by the user and as part of the proof. And then when it's received on the destination chain, there's a wrapped EOS that is minted in the wrap token contract. So wrap lock on one side, wrap token on the other side, and you have a bridge contract kind of sitting in between. So you lock your tokens on chain A. That gives you the proof that you use to mint the wrap token on chain B, and then these wrap token are exactly like the they are a virtual token, if you want, that represents the asset that's been locked in the smart contract on chain A. You can move it around, you can trade it, you can use it to do whatever, and then when you want to redeem that token for the original thing, you do the reverse, which is essentially you burn that token. That will also generate that inline action that now can be proved back on chain A, and then this unlocks the token from that pool and allows you to basically send it back to yourself.
Wow. So how do the keys work then? Just thinking of our talk about immutability versus non-immutability on EOS. What's the key structure then for that pool that's created on EOS in this example? Like, are those tokens, are they able to be voted on BPs? Like, I assume they're unstaked, so they're liquid, and no one's really managing that, right?
Well, I mean, it's these are very interesting questions, and we're kind of internally debating how to go about this. What we think is probably the best approach is to back in the day there was EOS New York, if you remember, there was a block producer on EOS mainnet. They came up with that article called asymptotic immutability of smart contracts, which I think is exactly what needs to be done. Like basically you start with a kind of like development phase where the developers release a smart contract. They hold the keys and they kind of have the ability to rapidly intervene if there's any issue or whatever, but they follow a decentralization timeline where like the first step is developers and control. Second step might be like a few like technical individuals or technical block producers become the co-signatories, the custodians of the contract. Eventually you can go to like a bigger group of block producers, eventually turn it over to the block producers of the network, and in the case of UX network, even eventually go to full immutability. No one can touch it. So it's kind of a process over time. It would begin probably with a fairly lean structure to be able to react quickly if there's any issues, to potentially push new features as they are being developed. But as confidence increases, as usage increases, as the amount of money that's held by the contract, we would also go and follow this gradual, I guess, like immutability, asymptotic immutability process that was outlined. So this is what we're looking at. We're also considering. We actually have two versions of that wrap token contract, wrap lock contract. One of which keeps everything liquid, and the other one stakes them to Rex and allows for voting with tokens as well. So this is another thing that we're debating internally about how we want to go about this. Because obviously, if you, most people right now, I think, are interested in maximizing their, I guess, like the yield of their EOS. They want to do obtain some I guess, passive yield on these things. So the ability to stake to Rex, for example, increase the total yield that you can get, and it seems to me a bit wasteful to not do so when you have the option. So, but we might end up also having both, having the two side by side, people that want to stake.
Yeah, you can have multiple options. If the user's executing or initiating the action, then when I'm sending my tokens over to UX, I can pick the non-staked, non-yield versus the staked and yield. But I guess if it's using EOS, is there still an unstaked period now, or did they remove that?
On EOS, there's still an unstake period, and there's with Rex, it's a little bit more, I guess, lenient, because with Rex, when you stake to Rex, it will take a few days to mature, but once it's mature, unstaking is instant.
Okay.
As long as they're matured tokens in the Rex pool, so it gets a bit complicated, but we've been debating these questions for a while. Like, these are there's pros and cons to both approaches.
And so, I think giving the option to the user is probably the smart one, and maybe
I think so too.
Starting with the idea of if the asymptotic immutability curve, eventually this gets owned by the BPs, they're not really going to want it. It would be a conflict of interest to have them having some sort of oversight as to how does this pool vote.
Yeah, and it's also even more contentious, I guess, because ultimately you're staking these tokens to another network. There's another network that ends up with with its own set of BPs, with its own governance and whatnot, and you would have some sort of let's say an interesting dynamic of for the governance of that contract. But again, it's we're quite big fans of the whole multiple options approach. So let the user decide. If the user feels like they want to have their tokens staked with all the pros and cons, they can go that route. If they prefer having their tokens immediately liquid and forfeit that additional yield, that's up to them as well.
Right. And so, and in terms of the interface, the UI that the users get to use, this is all on blockchain. So anybody could create a UI to perform these actions. Yes. However, your team has kind of created the initial one that you just showed us. So that would be the first kind of place that people can use this. Yeah.
Exactly. And a UI or a server process, because this could also be used by an arbitrage bot or things like that. If you want to develop this as a server side process, it's perfectly viable option as well. The only thing it requires really is a history solution. So you need to have the chain on which you implement this has to have, Diffuse or Hyperion or another history solution like that. We built it with Diffuse in our case, but the same information is available with Hyperion or with others. So that's the only requirement. You don't need anything else other than that. And we may even be able to do it with standard EOSIO nodes. There's a as you probably know, the ENF created a number of groups to work on various innovations and features in the EOSIO code base, and the API Plus group is essentially part of that effort, and they are working on broadening the feature set of regular API nodes. So we might be able to also squeeze in the last few bits that are required to have the solution essentially like work with just standard API nodes, which would also be like great for the network's health and everything, because it further reduces dependency on these few history node providers.
There's not many providers. Yeah, there needs to be greater incentive to get them going. That's a whole other can of worms. I've heard in terms of the transaction finality, that's something that's come up that I think CC3229, that guy, and as a solution apparently been looked at, and it might be workable. Is that something that if that happens and that comes to fruition and we have sub-second finality, do you anticipate being able to incorporate that into your solution here?
Absolutely. This is something I'm watching with great interest. I actually reviewed like a CC39D2 or whatever his name, his solution, and it's a good approach. If that gets implemented, definitely we will try to get it working with the UX network as soon as possible. And if you have, obviously, if your two chains now have that, like, let's say like 1.5-2 second finality, this whole experience gets a lot more interesting. Instead of taking 2 or 3 minutes, it takes 2 or 3 seconds. So that's really, really good. But yes, exactly. Like for us, what really matter is the time it takes for the block producers to reach consensus on the finality of a block. So if we go from 3 minutes to 3 seconds, definitely we're going to implement the same changes to the bridge, and we're going to also benefit from that.
Well, and this is the idea of this horizontal scaling, where you can have a smart contract that's real time-ish, right? Half a second. So you're used to this sort of, I click like, the thumb goes up, like I want that real time feedback. The idea, I remember we're speaking with Darren about how this IBC solution now, instead of just sending a token, which sure you can wait for your token to send, but if I'm doing an action that's like part of a game or part of some NFT minting or something that you want to be real time, it sounds like once that finality gets shortened, then you can have dApps on Wax execute part of their contracts on UX.
Exactly, and that's a very good point. And even further than that, you can also start thinking about having, for example, like this horizontal scaling of blockchains as well, where block producers could potentially run multiple blockchains in parallel and use this IBC approach to essentially sync them together. So now, like we already know that EOS on a single core is extremely fast. I think on EOS mainnet, the top that we reached was something like 4,000 transactions, but we benchmarked on our private testnet, we benchmarked up to 35,000 transactions per second without problems. So imagine having now like 100 parallel blockchains all running 35,000 transactions per second. Now, like you're talking in like big numbers. Like
that's right. When we all got into EOS at the beginning, one of the million transactions a second, and this is how it's possible.
Exactly. Now it's quite within reach, in my opinion. Like it doesn't require much more work than what we already have at this point. That 3 second finality to make it nice, and then like block producers running multiple parallelized versions that are able to talk together through that IBC, and then you have it. It's there.
So then it's once you build it, if you build it, they will come. So maybe we'll see if that works.
It's probably not the only thing that's required, but it definitely now scales to the levels that we need to see this mass adoption we're talking about. Because if you think about like what the future would look like if everything was running on smart contract platforms, like on blockchain platforms, well, you have all the transactions of the stock market going on through this. You have all the foreign exchange transactions going through this. You have all the payment processing transactions going to this. Add all that you want, like the digital ownership rights and digital property and like all of that stuff. That requires massive throughput. It's not going to work on Ethereum with like 15 transactions per second, So we need to think about like making these systems that will scale well into the like hundreds of thousands of transactions plus per second, if not millions of transactions per second. But now this is the first time that we have a path to get there that actually makes sense, that is manageable and can actually be implemented.
That's
So
amazing.
it's quite exciting stuff. Quite exciting stuff.
So, okay, this is all sounds quite is exciting. It's super exciting. In terms of next steps for you guys in UX, like, so I understand bridge, it's working. We've got some UI, looks great. So part of what has to come out with that in tandem is the AMM, the automated market maker. Can you kind of talk to is that something? I know there was some talk Q1. Things are what they are. Are we still? Is that still an achievable goal? Do you think, or we might have to push it a bit?
Well, typically our MM is pretty much ready. Like we're just like finishing polishing the UI and all of that. This being said, it's never the technology that drives our release cycle. It's more the commercial considerations. Right now, what we're doing is we're in discussions with all the other EOSIO chains as part of the EOSIO Plus group with sponsored by the ENF, to figure out a way to a framework, if you want, to harmonize and align incentives for the common development of the code base. And there's a good, I guess, like that's a good use case for the bridge and for the AMM, because now essentially like that would create a first of all like a marketplace where you can exchange tokens from all these chains between each other, but also the ability to create this sort of I guess like we call it supra token. It might not be the most sexy name, but to create this kind of I guess like index token that can now be used to fund the development of the code base. So as we are discussing this with other representative of these other chains, we're trying to agree on this framework that could now facilitate all of that. And essentially, like we would most likely try to also time the release of the AMM and the bridge with the release of that framework or that agreement, if you want, between all these blockchains. As a matter of fact, they are having a call as we speak. I had to skip it this week because of the call with you, but they are currently like discussing these things. Darren is with them, so that's probably what's gonna be the trigger for the release of both the bridge and the AMM if we reach an agreement or not with the other blockchains on how that should be implemented. And if we end up doing doing it like this, we would also probably have a lot of the BPs or a lot of representatives of these other chains to act as custodians of these smart contracts, because suddenly like all of these like parties would have a stake in that bridge as well. So we would use them as partners for the custody of these of the smart contracts. So this is kind of where we're at as we speak. Obviously, like we would love. We're very excited and very eager to release it, but we want to do it the right way without rushing things unnecessarily. So
Okay. Oh, fair enough. And so the AMM though is obviously a little more complicated. The UI for that is going to be a little more involved. So maybe we plan to do a follow-up, a little walkthrough.
That'd be great.
Form in advance of when you think you might be coming out with that then.
I mean, probably like sometime in the next few weeks, we could probably have that little demo again, probably just on testnets for the time being. But we could show the UI and explain a little bit how it works. It's quite interesting because this AMM is I guess like a multi-asset pool. Multi-pools, multi-asset per pools with dynamic weights that constantly rebalance itself, that is built to minimize market impact and to incentivize liquidity in a very nice, very interesting way. So it's quite unlike anything else that's out there. Like this, we spend quite a bit of time. Like we spend quite a bit of time in general researching what's being done elsewhere and trying to make sure that we avoid the same mistakes that other are doing and try to improve all the time over what already exists. Like we're quite cutting edge in that regard. So yeah, I'm very excited to release that one and start discussing it. This is mainly Darren's like brainchild, but it's I ended up implementing the smart contract, so I've got quite familiar with his approach, and it's beautiful. It's just like purely mathematically based, no I guess like a subjectivity whatsoever, all like hard math, like very objective, very solid
Perfect.
principles.
That's what a lot of crypto people like.
Yeah.
As we should. And just out of curiosity, then obviously you're going to need some sort of exogenous price feed, or maybe not. Obviously, will you have exogenous price feed? It'll be all based on
Just like the only reason we like the only exogenous price feed that it relies on is to display to the user the US dollar value of the assets, but internally it doesn't use any price feeds. It's all like self-referential. It's always expressed like as a base asset and a quote asset. These are like the two assets that form a pair, and the pair as a price expressed in the quote asset, and that's it. You don't have any dependency on any price feeds.
So it won't require a QED. I'm just wondering if your QED protocol is going to be used here at all, but no.
Nope, it's not required.
Perfect. Well, that's, I mean, you don't want to have dependencies ideally, like, right?
Exactly.
It's harder to break.
Every time you introduce a dependency like this, you create an additional, like vector of attack. You create an additional, like a surface of like vulnerability or whatever it is. And despite our QED Oracle protocol being very solid, we built it like specifically to kind of like harden these like critical data points that are gonna be, I guess, used in very like high stake decisions, like smart contract execution. Despite that, we still don't want to use this in an AMM like this. It has to be pure. It has to be like really just based on the relationship between the assets that are held in the pool.
Right. This is amazing. Well, Guillaume, this has been excellent. Really excited to see this come out, and I wish you guys like the best in terms of the negotiation with the rest of the chains, and hopefully they can get buy-in from them. It seems like an obvious, the whole Supra set token, Supra index token, like that makes a lot of sense in terms of a way to create that headroom and to fund the EOSIO protocol dev and have all the chains participate and have some sort of oversight and the governance of how that works. But yeah, it's the best solution I've seen come forward.
I think so too.
Solve that problem.
I think so too.
Right on, man. Okay. Well, thanks for your time. We'll do
thanks
this.
For having me, Chris.
I don't know if do you do much social media? Do you want people to follow you or do any of that kind of jazz, or just
not much, but definitely like I'm Guillaume on Telegram. So like anyone who wants to reach out and have a chat, I'm always open. And if not, you can also join the UX Network channel Telegram group. Follow us on Twitter, and this is where we publish our stuff.
We'll put all that in the show notes so people can follow you guys along.
Thanks.
Right. We'll do this again. Thanks again for your time.
Thanks, Chris. Bye-bye.
Bye-bye.